All right, guys, we're going to get started here. So welcome to the session titled How Verge Health Deployed a 24/7 Healthcare System on AWS. This is part of the AWS track. My name's Matt Mellon. I'm on the industry's marketing team at Palo Alto Networks. I specialize in healthcare, which also happens to be what this session's lightly themed to is healthcare, obviously. So before I introduce the speakers, just want to make a couple service announcements. Show of hands, how many healthcare providers do we happen to have in the audience? Okay, so a good number, great. So actually, regardless of whichever industry you're in, another thing that we've done this year to help promote intra-industry networking is added some icons to your badges. So for example, any healthcare folks should have a healthcare icon on your badge, so you can use that to network with other peers within your industry. Also have Fuel user groups. So if you don't know what Fuel user groups are, definitely find them at the expo. We have a number of special interest groups that help you, participate within your industries, both in online and in person. But let me introduce you to James Lawson, Vivek Desai from Verge Health here, and Jerry Miller from Cloudticity, who are going to talk you through the prezo today. So, guys, take it away.
Thanks. Go backwards here a bit. Hi, I'm James Lawson. How's everybody doing today? It's late in the afternoon. How many people are from Vancouver in the room? Anybody? Just a couple? Well, more than. Okay, come on now. You gotta more than a couple. So, I tell you what, I sure like Vancouver. I'm from Texas. As you can't tell from my accent, I have a small accent, but not much. Vancouver is just like West Texas, except I love how nice all the people are, just like West Texas. Almost identical except for the weather, the mountains, and the water, and the temperature, I guess. So, but almost just like Texas. Super, super nice people. You guys will be pretty excited. I know you guys came to the session. You're going to witness the only guy wearing a tie in the entire event. It's fantastic. You got to meet me. I'll sign something afterwards if you'd like. So, talk a little bit about Verge Health today. So the agenda is going to be, we're going to talk for a few minutes, at least I'm going to talk for a few minutes about Verge Health, who we are, what we do, and then we'll talk about our actual partnership with Cloudticity, and then talk about our use case review. And of course, you're only going to have to hear me for a couple of minutes, and then we'll get the smart people to talk, so it'll be fantastic. So a little bit about Verge Health. Verge Health is a company that has about 900 hospital clients across the United States. We service about 14,000 providers on a monthly basis, with a little over 17 million actions managed, and we'll talk about that more in just a moment, with about 500,000 active users. So you can see we've got a pretty large footprint across the United States, a lot of healthcare, a lot of hospital providers, and we've got a lot at stake, quite frankly. So what Verge does, we actually integrate governance, risk, and compliance. So if you think about GRC outside of the healthcare space, GRC is a pretty well-formed concept. Inside of healthcare, GRC is not so well formed. It's been, think about the airline industry, aviation, et cetera. GRC is, repeatable process. People understand that. But inside of healthcare, that's kind of a new concept for folks. So what we really do is we have documentation components for patient relations. We document events that happen from a reporting event with employee safety. And then also we take that from the other side and look at the contracts and claims. And by claims, we're not talking about UB-type claims, but these are claims when someone gets hurt and they actually sue the hospital. That's what we do. So from a healthcare perspective, understanding our infrastructure and network, healthcare itself, we have to become, healthcare is a super, super complicated animal, right? Our processes in most healthcare organizations are siloed. They're disconnected from normal policy and regulations. And there's new policies and regulations happening every single day, right? Their policy improvement efforts, you look at that from very specific, from a long time ago, right? Those process improvement efforts inside of healthcare have been, based on lean, et cetera. But what happens is you see those that occur and then they get to happen again and happen again and happen again. Every few years they get reinvented because of some new macro or some new event that comes out from the federal government. So In there, we have our patients, providers, and liability claims. So we service all three of those pieces. You know, for us, the voice of the consumer really is not integrated into a safety and compliance framework. We have to actually do the job and make sure that we create that framework for the hospitals there. So that result is really healthcare organizations today, they have an unacceptable safety and compliance risk. So how many people in the audience have heard, you know, through multiple media outlets that there are errors that happen in hospitals every day, right? Everybody. It's a big deal from a hospital perspective, and it's a huge deal from the news perspective, because it's a big news item. So you look up there, you got a couple of different unfortunate events that have happened that make the news, and it's always a sensational story for news outlets to cover, for sure. So for us, GRC is really the current best opportunity, because we know that by looking at that industry, if those organizations that are in the top 20% of GRC compliance, they actually generate 3 times as much EBITDA as those in the lower group. And that's because they're more efficient in the processes that they're working, they have less harm to patients, they're paying out less, and they have repeatable processes, so it's easier to train folks, et cetera. So if you look at financial performance only, that's highly correlated, though, to the level of integration, or really the integration across risk control and compliance functions. So if you think about that from just the finance piece, you're saving a lot of money, but also it's correlated to actually the risk and control piece as well. So harnessing those components from a technology to support risk management is really the greatest opportunity or weakness for most organizations, because they can't see 10 million more patients to become more profitable, right? They have to take what they have right now and become more profitable. So with our Converge, and again, I could probably talk for the next 2 or 3 hours about our platform and what we do, but you guys are here to learn more about really what we did with AWS. To understand a little bit, though, very quickly, our Converge platform, we have 3 components of that platform. First component is the compliance side. The next is practitioner management, and the other is patient-employee safety. So all those 3 are together in our environment as a platform for hospitals to deploy. In understanding the platform technology, we actually migrated to AWS last year, beginning in October. AWS is a great partner of ours, and we've leveraged some other great partners as well to get there. But certainly by adding our footprint to AWS, we've been able to scale up and also have a lot of, I think, better opportunity to fix problems, identify problems before they become problems, and of course be able to scale appropriately. So as we look at what we're doing too, the ability for us to cover all those silos also adds our ability to do vendor consolidation with best practice implementation. We also have components from integration perspective. We have protected safety and quality data that's outside of the electronic medical record, so that lawyers can't go after that data because it's patient safety work product. And of course, we've always been developed on a SaaS platform. So that's the way we've been forever. We just grew up in a normal data center. So understanding that very complex environment with a whole lot of hospitals and a whole lot of data, it was paramount for us when we moved to make some smart decisions about our environment, and that's where I'll kind of hand it over to Vivek Desai.
Thanks for that introduction there, James. So as you guys know, moving into AWS is no small feat, especially since James said we're starting in October and we got to be live the first week in December. Made it even more complicated for the time frame we had to do it in. We ran into a whole host of problems related to how do you do high availability for our SaaS platform, how do you manage multiple AZ failovers if those were to occur. I'm going to go over some of those business cases. The other things that we tackled, and I'll talk about them later on, is how do we get all of our users to connect securely using a product, and then how do we ensure that that is who they say they are. So I'll kind of review that as we go along through the slides. One of the first things that we had to tackle when we went into AWS, and most of you may or may not know this, is for AWS best practices from the Elastic load balancer, it should all be, the traffic should go to it from a DNS-based way for best practices, but traditional firewalls, including Palo Alto Networks, rely on IP-based routing. So right there is our first problem, is how do we get IP-based routes, which are static, over to a DNS-based Elastic load balancer, because those IPs will change, and they do change fairly frequently. In general, this is kind of, at a very high level, our current setup, but this problem will happen to anybody that tries to move into AWS. So how do we go about tackling that problem? Well, the good thing is we partnered with a really, really smart company in Cloudticity, and with their help, we were able to come up with what I consider a fairly effective, low-cost, and automated solution to this specific problem. And the answer was we were going to use a Lambda function, and its sole purpose in life is to basically look at the network NAT rule destination IP address and sync it with the elastic load balancer VIP IP. That's all it does. But that in and of itself lets us stick with an external perimeter firewall like Palo Alto and keep the elastic load balancers and the way Amazon kind of wants it done in a DNS-based fashion. This allows us to have that flexibility that we need for another topic that we'll also talk about, which is allowing for that multi-AZ failover. Doing it this way allows us to also take that into account. We'll go into some details on that in a little bit. What I am going to do at this time, though, is I'm going to hand it over to Jerry Miller from Cloudticity. He's going to kind of open the hood up a little bit and show you what some of the possible deployments are and talk a little bit more in depth on the technology.
Great. Thanks, Vivek. All right, my name is Jerry Miller. I'm the founder and chief technologist at Cloudticity. We help healthcare companies be successful on AWS. Verge Health is one of our favorite customers, and we're happy to be here with them. Let's talk a little bit about the overall. I'm going to step out from behind the podium because I'm too short. We'll talk a little bit about the overall architecture. We'll talk about some of the problem space that we're trying to solve. We'll talk about the sequence of events, and then we'll dive into a little bit of code. The solution that we helped design is open source, and I'll show you the GitHub repo. So hopefully this will help the community at large, and somebody else can leverage some of the work that we've done there. So a few things about the architecture that we have here, right? So one is that traffic comes in on an elastic load balancer, which is really what you want. For example, if you want to auto-scale, if you want to take advantage of multiple availability zones and the high availability that offers, and if you want to have effective HA failover for a disaster recovery perspective. Vivek mentioned some of the challenges here. One is that routing doesn't really happen at layer 7, and so we can't route to a host. ELBs, on the other hand, are purely host name based because the underlying IP addresses will change. They have multiple IP addresses. And so mixing the traditional routing scenario with the way that AWS works with load balancing, with host names, and with a shifting set of IP addresses is a real problem. So what we've done is allowed a continuous review of the IP addresses of the ELB and an API-based update of the routing tables inside the Palo Alto devices. We also, if we sandwich that between two ELBs, we can build a multi-availability zone auto-scaling group that can fire on a number of CloudWatch metrics. So for example, a traditional metric might be a CPU utilization or a network bandwidth utilization. But we can emit custom CloudWatch metrics, number of Global Protect customers connected, things like that. And so we can use a variety of interesting metrics to trigger the automated scaling that AWS provides, which gives a great customer experience because things never slow down, but also gives a strong amount of cost optimization. And because the scaling happens automatically and because things like routing tables are fixed up, we are able to do this in a fully automated fashion. How many people use AWS today, out of curiosity? All right, so most of you, okay. So we'll answer questions at the end. If there's any terminology that was unfamiliar, I apologize, and we'll clarify at the end. So then the second piece is what happens how do you get to that second load balancer? And that's where we have to do the automated updates. And the third piece is every once in a while, an availability zone on AWS will fail. It happens. And so how do we do things like affect a failover to a secondary when we have things like multiple Global Protect customers connected, when we've got a few hundred point-to-point VPNs with external customers, when we've got routing tables? What does that look like and how is that affected and how can we actually implement a failover not in minutes or days, but literally in sub-second times? So The sequence of events, we do a few things, and we'll dive into some code, and then I'll show you the repo, and you're welcome to use the solution yourselves. So we have to do a few things. One is every minute or so, that's as often as you can fire a CloudWatch event. So every minute, we trigger some workflow that goes to the active Palo Alto VM series firewall and gets its latest configuration. That way, anybody that updates configurations doesn't have to worry about doing anything other than saving and committing. And so we save that off to S3, and so we always have an up-to-date backup configuration on S3. We also have to update NAT rules, and so every minute we iterate through a series of elastic load balancers that are tagged, and we'll talk about why that's important, and we get their latest IP addresses, and we iterate then through any active Palo Alto VM series firewall, and we update its NAT rules to make sure that it always has the latest IP addresses. And so that way we're kind of merging the different layers of routing and natting. One of the interesting elements of this, I mentioned that we're doing this based on tags. So in AWS, as those of you who are there know, you can tag resources with an arbitrary number of key value pairs. And those tags are queryable. And so what we can do is, in pseudocode speak, we can say, iterate through all of the elastic load balancers and hand me anyone that is tagged, Palo Alto update. And so if we add additional load balancers or we change the architecture of the AWS network footprint, all we have to do is ensure that the new resources or any deprecated resources are tagged appropriately, and the solution works the same without any changes to code. So we've built that type of flexibility with the hopes of maintaining a fully automated solution that's hands-off, that doesn't require a lot of maintenance, and in the end, it just works. So if there is a failure, if an AZ goes down, if an EC2 instance goes bad, if the underlying hostware, if whatever happens, if there's a failure, that triggers a set of workflow. That will trigger the execution of a set of Lambda functions that will move the traffic to a secondary Palo Alto firewall device, that will configure that device with the saved configuration file, and begin to move all sorts of things, right? So we've got to make sure that the routing tables and the NAT rules are updated. We've got to make sure that they're tied to the correct backend IP addresses of the current ELBs. We've got to move things like IP addresses. We've got to move elastic network interfaces. Moving ENIs is not all that easy because it'll be in a different subnet in the secondary AZ. So now we've got to update all of those old routing tables to reflect the new subnet. And so there's a whole bunch of iteration through the config file with just-in-time updates. Then we have to remap elastic IP addresses. And finally, we have to reconnect what can be hundreds to, for some of our customers, thousands of point-to-point VPN connections. And we need to do that in a way that is as transparent to the end customer as possible. And in this case, it's seconds of response time. And then finally, we send out alerts, which triggers a whole bunch of workflow that causes systems and people to begin to postmortem. The first thing we do is we let the computers fix the computers so that the end customer is unaffected. And then we trigger workflow that causes people to do postmortems. We deploy all of this using CloudFormation, which is a critical piece, because CloudFormation lets you define in either JSON or YAML format the end state of an AWS configuration, and then you can deploy that to your heart's content. You can deploy it repeatably. It's automated, so it doesn't break, and it happens the same way. It's predictable. It gets logged. But it's also parameterizable. And so we make sure that we're able to specify some things that might change from deployment to deployment. And so by feeding parameters into a standardized CloudFormation template, we can do things like give the customer the flexibility on what S3 bucket or what S3 key. If certainly the IP address, the elastic IP of the Palo device's management console is going to be different per customer. Things like admin usernames. Passwords, of course, we don't pass in. We use the AWS parameter store for that, so it's encrypted as a secret string. but we can specify different security groups and subnets. And so in doing so, we're able to give customers a highly flexible solution that still is automated and doesn't require code changes every single time they update. And you can make changes to the CloudFormation template and execute those as change sets. So your infrastructure updates as your infrastructure evolves doesn't happen manually. It happens through a series of change sets and can go through a defined pipeline stage with stage gates and approval processes. Some of the things that come out of this, some of the assets, there's a NAT rule Lambda function, and so we've got a series of Lambdas that the CloudFormation creates that execute the code. We'll look at some of that. There's things like IAM roles that define the permissions. So the Lambda code only has permissions to do the limited subset of things it needs to do. And so your blast radius is significantly limited if we introduce a bug inadvertently. We add things like timer rules. So that's a CloudWatch event rule that essentially is a cron job that indicates how often these things should run. Some invoke permissions. So all of these fully automated native AWS solutions that are really driving automation in a way that lets us and our customers use the VM series firewalls in really innovative ways and to fully leverage the elasticity and the programmability of the AWS infrastructure. How did this work for you?
So there's some pros and cons to this. The biggest pro, obviously, for James and I's DevOps team was we're only using tagging, which is the way that we want to do things. Tagging is king in AWS, plain and simple. When we get to use taggings, we get to use CloudFormation templates, so we automate that. The best part about this is there's no config files. And I know a couple people are shaking their heads, they know what that means, right? If you don't have to keep updating config files, your engineers aren't wasting time doing that, so you're allowing them to be more efficient by not going in and just doing it the old way. The new ways are a little bit more dynamic, a little bit more flexible, more automation, so you have a repeatable process. Some of the drawbacks, and this is very nitpicky stuff, but it is stuff that we've kind of seen, is Lambda functions by nature only run once per minute. Some people may not have that risk appetite to have the triggers fire a little bit sooner. I know Jerry and his team, they're working on updating the code to run it as a service inside of a Node.js. When that's done, you should hopefully be able to run that faster than a minute, so that'll give those people with a little bit lower risk tolerance the ability to run it at whatever time frame they want to try to keep it from triggering when it should or shouldn't. One of the best things about this is Jerry and his team have actually made all of this open source, and there's a GitHub link at the bottom of the screen right now. So it's open to you guys to use however you want to, and we want to provide that back to the community. So please feel free to take it and do with it what you want, but it should help kind of add that level of resiliency and flexibility into your network environment, especially if you're using a SaaS solution. It's just going to be a clean and efficient way to add to your growing automation tool belt. With that being said, one of the other topics that we want to approach with Jerry was multi-AZ failover, and talk a little bit more about the actual code that he used for the Lambda function. So I'm going to give it back to him to kind of dig under and get to that real technical layer for those people and kind of look at the code.
So here's where half of you guys perk up and the other half go to sleep. I get it. So obviously we can't go through all the code, but I want to talk about some very specific, interesting use cases that we identified, some challenges we ran into, how we solved it, and hopefully if you guys are using things like Node.js or Lambda, particularly in conjunction with Palo Alto VM series firewalls, hopefully some of these snippets will give you some ideas and is useful to you. So here's some examples of where we're doing things like parsing out IP addresses from XML responses, doing things like NS lookups and resolving IP4 addresses. These are snippets from the code, for example, where we're parsing return XML from API queries into the Palo Alto firewall, or where we're querying ELBs and pulling out current addresses so that we're able to continue to keep everything updated and in sync. We've got a whole lot of custom code that interacts directly with the Palo Alto Firewall's API. And so we're both querying the API for information, what's your current state, and we're doing things like using the API to do updates And so a lot of the configuration file is XML based. So when we're working with configs, much of what we do is XSL queries. So we're doing XPath queries with XSL, querying in to retrieve particular nodes of the configuration file. We retrieve that through the API. We extract information from that. We do interesting things with the information. We do we do AWS updates. We do firewall updates, and then persist the state back into the running system. So here's an example of pulling together an XPath query, issuing it as a RESTful post, and then parsing out the response. If anybody's ever coded with Node, particularly if you come from a more procedural background, it's really, really awesome, and it's really, really maddening because everything is asynchronous. And I cannot overstate the word everything. It takes a long time to get used to. And so in order to make this more maintainable both for our team, and we have some really strong Node developers on our team, but there are some times when you need a procedural execution, where you need to go, this happens, then this happens, then this happens, and if this fails, either do or don't continue on. And those types of procedural sequential runs inside of Node.js are not really well suited for the language. And so if you go down this path, there are some useful libraries that we discovered and leveraged. So async is a really cool library that lets you specify, like here, there's an async method called waterfall that you pass it an array of sequential functions, and it will execute them sequentially. And so we have to do things like update the tags before we can go ahead and get a file name and then do something with that file name. Async also has parallel execution. It has branch execution. So if you need to introduce some sequential management of your Node.js code, look for our library. Async was a great library for us. So that you can see, it really does stuff. Like we have code that actually transfers elastic IPs, and so that uses the AWS API. We have code that updates functions and configurations inside of the Palo Alto firewall. So, example code of doing real things using Node.js. So all of this was in search of, there's a lot of technical detail, but it was in search of supporting the overall business mission of Verge Health that James talked about, and some very specific business use cases that I'll ask Vivek to come back up and talk about. Thank you.
So once we put the Palo Alto Network firewall in, I'm going to talk about two quick business use cases here that were very interesting to us. Once we put it in, we started to get traffic, as you do, from everywhere, and we started to look at it. And then we started to see a significantly large amount of traffic from what I consider very odd places, like Ireland, the Democratic People's Republic of Korea, the Islamic Republic of Iran. So I kind of shot a quick screenshot to James and going, just taking a guess here, but I'm suspecting, North Korea and Iran probably don't use Verge Health. So just a hunch. So is it okay if we kind of take this and see what we can do with it? Because the end state here is to stop that traffic from entering our network. He said, yeah. So working with customer services and sales over the course of a simple timeline that I laid out here, I went through and we tried to figure out where's the good traffic coming from, or where should it at least be coming from. In a high timeline, we took about 3 weeks to gather the data, took about another 2 weeks to analyze the data, a week to review it with James, change management, and a couple other people to make sure that here's what we're going to be blocking, here's why. And then Friday night maintenance window, we put it in place. The results of this were what I expected, but then also there was a lot of unexpected results too. So what we ended up doing was we blocked traffic from locations where we don't have any business, so that's kind of a duh statement. Through that, we were able to lower the amount of data that was going through our SIM. That was an indirect thing that I didn't quite think about when we did it, but yeah, I guess when you look back on it, reflect like, yeah, you'll have less traffic going through your SIM. On top of that, from a board point of view, what we were able to show demonstrably was we had a 30% reduction in connected sessions, which translated into a 29% reduction in traffic. Now, that's kind of pretty big when you think about it in AWS terms, because AWS charges you for everything. So one of the other direct things that I didn't post on here is there's actually a fairly significant cost savings, because the iterative effect of not having our IIS servers generate that much log files, shipping it to our SIM server to store all those log files, and just basically on the storage side of it, we were just seeing a fairly decent reduction in that. So it's kind of like, I'm from Chicago, so it's like the Phil Jackson triangle. We had a security project that was a relatively quick turnaround, about a month and a half. We were able to increase our overall security and demonstrate it, but to James and everyone else at the executive level, it saved them money, right? So that was kind of a big win. So I would say I don't really see a reason why you wouldn't want to at least try this. I'm almost certain everyone in this room that's in healthcare probably has no business having traffic from Iran hit your servers or North Korea. It's just one of those hunches, but you can kind of go through that list. Palo Alto Networks has a fairly extensive geo filtering list. You can go through it. They got nice reports in there. You can print them out and just kind of go through it with your leadership team. Like, do you mind if we block traffic from North Korea? They're probably going to say that's fine, and just kind of keep going through that list over and over again, and you're going to show a pretty substantial value pretty quickly. If you're in AWS, you'll probably see a nice gain in storage too. It's just the cost of storage and how much traffic it generates. It's a win-win situation. The next business use case is how we're implementing defense in depth using Global Protect. And I put up the statistic from the 2017 Verizon Data Breach Report. 81% of all hacking-related breaches leverage stolen and/or weak passwords. So I make the assumption in this scenario that at some point my users' credentials are going to get stolen. What can we do in IT or infrastructure to make it just that much harder for an actor to use those credentials? And again, right, kind of sticking to that triangle, it's got to be low cost or no cost. It's got to be very easy to deploy. And the killer is I don't want any end user interaction, right? I could just go out and implement a Duo Security or product like that, but it's just another layer that a customer or end user needs to use and just creates more friction than anything else. So we looked at Global Protect and see if there's anything in there, and sure enough, right, Global Protect did have something. So using Global Protect, we implemented host information profiles, or HIP checks. I don't know if anyone here has actually used them, but you should definitely take a look at them because it's part of your subscription if you're in AWS. And HIP checks, basically, they check an endpoint before allowing it access to your infrastructure. It makes sure that certain criteria, whether they be true or false, are adhered to. So we started some fairly rudimentary HIP checks, and we keep expanding on them. First, we started with, do you have antivirus installed? Yes or no. If it says no, you automatically can't connect. Then we got a little bit more sophisticated. Do you have our specific antivirus installed? So now you have the weak passwords that were stolen. You have the username. Now the actor also needs to have our specific antivirus installed. We then added a simple one where we have to do whole disk encryption anyway. So we added, are they using an encrypted disk? That's another HIP check we added. The interesting thing about this is we kind of stopped there, and we started to see that, hey, we can also implement this on our contractors and our contractors' VPN group. So if your contractors are having a BYOD sort of policy, you can enforce your IT security policies on all your contractors if they're using BYOD. You could ensure that they have an antivirus program. You could even specify if it's a specific one you want them to have. You could make sure that automatic updates on your AV is done. The last scan is within X amount of days, and so on and so forth for antivirus. You can do the same sort of checks for malware, and for disk encryption, if you require it, you could do that. So that's really good. We've gotten some great feedback on that, because at the end of the day, the best feedback is the users don't know they're doing it, because this is all done at the Global Protect agent. So as long as they hit connect, we're checking it and then providing them, granting them access once they've passed those checks. We've now gotten that level of assurance, and we're moving on to a POC of using the custom checks for POC right now. I'm currently testing out Windows registry keys andplists in Macs. So that's just to add that additional layer. Yeah, they can probably figure out how to get our antivirus if they so choose to. Yes, you can encrypt the disk, but so what's next, right? So they have custom registry checks. We're trying that in POC, and it's pretty simple. If you have a domain with everyone joined to it, you can inject custom registry keys on all your machines. So we're trying that out right now to see how easy it is. And the initial experiments are, yeah, it's super easy, right? Click on it, put some random hash value in a registry key, make sure nobody knows about it, add that to the Palo Alto Networks firewall, and off you go. For Macs, we're trying out plists, so we're still trying to figure out the logistics of that because James owns a Mac. He's one of 2 people that owns a Mac, so I got to make sure that he can connect to it securely, or else there's going to be some problems. But in a nutshell, this is another use case that kind of meets that Phil Jackson triangle. Relatively easy security project. Took me about a week or 2 at the most. High security value, low cost because it's part of your subscription service again. So this is something I think you guys should look into. And again, it's just another way to demonstrate to James, senior managers, or even your direct managers the value of using Palo Alto Networks firewall. But on top of that, all the other cool stuff that's in there that you may or may not be using. With that, are there any sort of questions that we could answer?
This is for Cloudticity. What is the core difference between the ELB sandwich code that Palo publishes and the one that you have? Besides that you're using JavaScript and guessing Node.js. Versus Python based.
Yeah, so the methodology is similar, Node.js, and we made it integrated with the failover code that we built as well. And the other significant difference is the code that they publish assumes a single availability zone, and ours assumes multiple AZs. And
Theirs goes in shippable, they just, you have to have a firewall for AZ though.
right, yes, yeah. But failover wouldn't work across AZs. And so we updated that to include configuration that would also allow a failover to occur if it had to. And then we added all of the remapping of ENIs and the remapping of EIPs.
Okay, so you're saying that yours you do support
Jerry,
Yeah.
that's not, so the ELB sandwich he's referring to actually does do a firewall in multi-AZ.
Yeah.
Yeah, so I'm not sure that you might be referring to traditional HA, but the ELB sandwich that we do is establishes a firewall in a single firewall in multiple AZs, and then we leverage the load balancing to take advantage of and execute the failover.
So when we built it, the code did not allow failover, the code that was provided. And so we had to build that. And then there were some distinct use cases that our customers have that also hadn't been factored into the original code, which were things like point-to-point VPNs. So a lot of our customers, like Verge Health, has multiple VPN connections to their customers, hundreds. We have health information exchanges that have thousands of point-to-point VPN connections. And so we had to factor in the ability to maintain and fail those over as well. So there were a number of use cases that the original set of code that they provided solved the problem at a high level, but we had some very specific use cases for our customers that we need to go sort of the next turn of the knob and iterate on that.
To be clear, the ELB sandwich that we put together didn't exist when Jerry did that.
Gotcha.
Okay, yeah.
With traffic coming from the internet and hitting an ELB, how do you force that traffic through a Palo Alto first? That's what you guys had in the diagram, right?
Yeah. So,
Maybe I'm having a brain fart, but how do you do that?
yeah, so that's why it's an ELB sandwich. So there are things that can be passed through an ELB that can go to multiple AZs and then back, right? And so the routing tables are set in the firewall are set to point to an IP address of that second ELB. So it can route, it can pass the outer ELB will route the traffic to either firewall, which will then route it back to the inner ELB. And that allows for an auto-scaling configuration. There's other traffic that has to be tied sticky to a single firewall, such as point-to-point VPNs. that can't go through an ELB. And so there's some traffic that gets routed through auto-scaling. There's other traffic that is sticky to a single AZ and that would have to follow the process for failover to, for example, reestablish point-to-point VPN tunnels in the case of a failover. All right, I think that's it.
Perfect.
All right,
Thank you,
well,
guys.
thanks, everyone.
Appreciate it.
Yeah, have a great day.